Okay, we'll quickly look at the first bit. I'll then give you another minute or so to make sure you finish it off. So we're going to start with our BR, okay, and we've got the FeBr3, okay, and it acts in exactly the same way as I said as a Lewis acid. So the lone pair of electrons here can react. That's going to give us Br plus and FeBr3, and the Fe has a minus. So we can equate that to being Br plus, okay? So we can say that is equivalent to Br plus and then FeBr4 minus. Okay, so take that bit of information and then do the other bit. Okay, so now apply that, add the electrophile to the benzene ring. So have a minute to have a go at that and then we'll move on. So to start with, the one in the middle is the one that's given off its electron. Okay? So at that point, it's got a positive charge. What would then happen is the other bromine, what we're saying is it kind of equals the other bromine, and also you give its electron to the bromine with a positive charge, and that ends up okay, we'll move on. So what we can say is we've got our Br plus, we have our electrons in our ring. We can use those electrons to react with that Br plus. Okay. So then we've got our positively charged carbocation. What I wanted to do was just practice drawing the resonance structures. So recognise that we can take the electron density from here, move it round. Okay, and then we do the same thing again. So we can move that electron density around the ring, or that lack of electron density around the ring. But ultimately, at the end of it, we've got our hydrogen, and we know that we can form that Br minus. That can grab the hydrogen can give its electrons away. And we can reform our aromatic ring. Okay. Just one thing, just to reiterate that in reality, it would look more like this, that the electrons would come out and attack that bromine. The electrons would then move to neutralize that positive charge. But you end up with the same thing. Okay, so if you just put Br plus, again, that's fine. If you really want to show true understanding, you show the one at the bottom. Okay. So that's the addition of a halogen. Okay, you can hopefully see that we've just done one reaction mechanism. Okay, it's just the one standard reaction mechanism. The only difference is that we've had to create our electrophile. And what you'll see through a lot of the stuff that we're going to do over the next 2 weeks is fundamentally we're using the same kind of reaction mechanisms, but there are some differences to do with, in this case, how do you make your electrophile? I'm going to show you another example in a minute that uses exactly the same mechanism for the addition, but we've got to do a bit of arrow movements to get our electrophile. So when you're revising this, don't think, my God, there are so many mechanisms to learn. The general mechanism is the one that you really need to learn and understand, and then you need to understand, well, how do I make something electrophilic? How do I make it nucleophilic? And that's a different question. It's a slightly different bit.